So in the last class we talked about applications of the distance formula. In today's class we will do some examples based on the distance formula. So we have a point, 3 points. Point A is 1, 2. Point B is 3, 6. And point 6 is 5 and 10. 1, 2, 3, 6 and 5, 10. So we are given 3 points. We have to prove that the points are collinear. 3 points, their coordinates are also given, and we have to prove that the points are collinear. What does that mean? Collinear means they lie on a straight line. Okay? So 3 points, they lie on the same straight line. So to prove that, we first find the distance between A and B, AB, by using the distance formula. So it is 1 minus 3 square plus 2 minus 6 square. This is minus 2 square minus 4 square. This is 4 plus 16, 20. This is equal to 2 square root of 5. Right? Then we find the distance between B and C. What is the distance between B and C? 3 minus 5 using the distance formula. 3 minus 5, 6 minus 10. 6 minus 10 square. This is equal to minus 2 square minus 4 square. 4 plus 16, 20, again 2 square root of 5. And then we find the distance between A and C. A and C. What is the distance between A and C? 1 minus 5 square plus 2 minus 10 square. Right? So this is minus 4 square minus 8 square. This is 16, 64, 80, 16, 5, 4 root 5. Square root of 80 is 4 root 5. So we have AB plus BC two square root of 5 plus 2 square root of 5, 4 square root of 5. Right? 2 square root of 5, 2 square root of 5 is equal to 4 square root of 5, which is equal to AC. 4 square root of 5 equal to AC. So we have AB plus BC is equal to AC. So if we take that ABC are 3 points like this, okay, and if AB plus AC is equal to, AB plus BC is equal to AC, then that is possible only when C is in the same straight line, not here but here. All these 3 points are on the same straight line. Only then AB plus BC is possible. AB plus BC is equal to C is possible. Only when B lies between A and C. That means all the 3 points are on the same straight line. And what does that mean? That means the 3 points are collinear. Hence, A, B, C are collinear. Hence, it is proved. It is your answer. Okay? By using the distance formula, we find distance between AB, then BC, then AC, and then we find that AB plus BC is equal to AC. So this is possible only when B lies between A and C on a straight line. That means the 3 points are collinear on the same straight line. So this is one application of the distance formula. So 4 points, A 1 and 1, B is 5 1, C is 5 5, and D is 1 5. 1 1, 5 1, 5 5, and 1 5. So we are given 4 points. We have to prove that joining the points one after another in sequence, they form a square. So for that, we will find the distance between the points using the distance formula. So first we find the distance between A and B. By using the distance formula, we get 1 minus 5 square, 1 minus 1 square, 1 minus 1 square, right? So this is equal to 4 square, 1 minus 5 is minus 4 square is 16, 1 minus 1 is 0, square 0, 16, that is 4. BC is 5 minus 5, 5 minus 5 square plus 1 minus 5, 1 minus 5 square. This is again equal to 0 plus 1 minus 5 is minus 4 square is 16. Again this is 4. Then CD. What is the distance between CD? 5 1, 5 minus 1 square, 5 minus 5. This is equal to 5 minus 1 is 4, 4 square is 16, 5 minus 5 is 0, 0 square is 0. So 16, we get 4. Then AD or DA. DA is how much? 1 minus 1 whole square plus 1 minus 5 square. We get this is equal to 0. This is again equal to minus 4 square, that is 16. This is equal to 4. So AB, BC, CD, DA all are equal. 4, 4, 4, 4. So we have 4 equal values. So we can construct a shape like this. A, B, C, D, right? Where AB is equal to 4, BC is equal to 4, CD equal to 4 and DA is also equal to 4. So all these are 4, 4, 4, 4. So it is either a square or a rhombus, because rhombus also has all four sides equal. Now to prove that it is a square and not a rhombus, what we need to do? We need to prove that if we create diagonals from A to C and B to D, then the diagonals are also equal. So what is A to C? A to C is 1 minus 5. 1 minus 5 is square plus 1 minus 5. 1 minus 5 is square. This is equal to 1 minus 5 is minus 4. Minus 4 square is 16. 1 minus 5 is minus 4. Minus 4 square is equal to 16. We have 32. 4. How much it is? 2 into 2 into 2. 4 square root 2. Right? Again, BD is equal to how much? BD. This is equal to how much? 5 minus 1. 5 minus 1 whole square plus 1 minus 5. 1 minus 5 square. How much it is? 5 minus 1, 4. 4 square is 16. 1 minus 5 is minus 4. Minus 4 square is also 16. We have 32 again equal to 4 square root 2. So we have, hence AB is equal to BC, CD equal to DA. All the four values are equal and diagonals AC and BD equal to BD. AC is equal to BD. 4 square root 2, 4 square root 2. Hence, the shape is a square. Hence, it is proved. Okay. So by distance formula, first we prove that all the four arms are equal. So the shape can be either a rhombus or a square. Now to prove that they are actually a square and not a rhombus, we find the values of the diagonals also, and we see that the diagonals are also equal. So in a square, diagonals are equal. In a rhombus, the diagonals are not equal. So this is important, that you have to find the values of the diagonals also and then prove that they are also equal. If that is the case, then you have a square. Okay. So this is another application of the distance formula. So we have used the distance formula to prove this. We have 3 points, 2, 1, B is 6, 1 and C is 4, 5. So we have 3 points A, B, C, coordinates are given. 2, 1 for A, 6, 1 for B, 4, 5 for C. So we have 3 points and we have to prove that they form an isosceles triangle. What is an isosceles triangle? When two sides are equal. And when the opposite angles are equal, of course you don't have to prove that the opposite angles are equal. If you can prove that two sides are equal, then it is an isosceles triangle. Okay, the triangle is like this. If xy is equal to xz, suppose if two sides are equal, then that is an isosceles triangle. Two sides equal, that is what you have to prove. So what we will do, we will find out the distance between all the points in turn. First we find the distance between the 2 points AB. What is AB? 2 minus 6 square, 1 minus 1 square. This is equal to minus 4 square is 16, and this is 0, 1 minus 1 0, so it is 4. What is BC? BC is equal to 6 minus 4, 6 minus 4 square, 1 minus 5 square. That is 6 minus 4 is 2, 2 square is 4, 1 minus 5 is minus 4, minus 4 square is 16. It is 20. So how much it is? It is 2 square root of 5. Then we find distance between AC, A and C. This is equal to 2 minus 4 square plus 1 minus 5 square. Then we find how much? 2 minus 4 is 2 square, 4, 1 minus 5 is minus 4 square, 16 is 20. It is equal to how much? 2 square root of 5. So we have AB, BC and AC or CA, whatever it is. BC and AC, they are equal. BC is equal to, so BC is equal to AC, right? This side is equal to this side. Since two sides are equal, hence we have an isosceles triangle. Because in isosceles triangle, two sides of the triangle are equal. Okay. Hence, the three points form an isosceles triangle. A little bit of modification needed here. BC is equal to AC. So this condition alone is not enough for the 3 points to form a triangle, an isosceles triangle in this case. Why? Because for any 3 points to form a triangle, then the summation of any two sides should be greater than the third side. If xyz is a triangle, then summation of xy plus xz will always be greater than yz. Xy plus xz will be greater than yz, the third side. Okay, this is important. So we have proven that BC is equal to AC. So if you replace this as ABC like this, then BC is equal to AC. This is proved. We have proved that BC is equal to AC. Now we have to prove that BC plus AC is greater than, what is the third side then? Third side will be the side AB, right? This side. So AB, BC plus AC you can write, and BC plus AC. What is BC? 2 square root 5, AC 2 square root 5. So 2 square root 5, 2 square root 5, 2 square root 5, it is 4 square root 5, which is greater than 4. What is 4? It is AB. So it is greater than AB. So now we have two sides equal and the summation of the two sides greater than the third side. So it is definitely a triangle and the two sides are equal. Now it forms, we can say that they form an isosceles triangle because it forms a triangle, of course, and they also form an isosceles triangle because the two sides are equal. Hence the 3 points form an isosceles triangle, and that is your answer. By the way, you may be asked to prove that 3 points form an equilateral triangle. That is another version, another type of question similar to this question. Here you are asked to find the isosceles triangle. Sometimes you are asked to prove that they form an equilateral triangle. So it is same, the procedure is same. In equilateral triangle, what you have to prove? You have to prove that the three sides are equal. AB is equal to BC is equal to AC. Then the three sides are equal and that forms an equilateral triangle. Okay? Procedure is same. Finding the distance between the points in turn, AB, then BC, then CA or AC, like this. So in exam, the distance between 2 points, it is not very much asked, but if they ask, it is for 1 mark usually, and mostly they test the concept by giving you such questions like use the distance formula to prove that 3 points form an isosceles triangle, or 3 points form an equilateral triangle, or that 4 points form a square, or 4 points form a rhombus. This type of questions, they test that how much concept you have on the distance formula. Okay, so practice this. So that's it for today. In the next class, we will do the section formula and some other concepts from the chapter 7.